All right, just wanted to talk about the solution for question 16, part B. If you copy the notes I did in class, I actually had the correct physics, but I had the incorrect math. When I multiplied 110 kilograms times 1.2, when I did it in class, I was modeling the larger player by himself. And I said 1,320. I should have said 132. 110 times 1.2 is 132. So my physics, if you took notes in class, was correct, but I made a math mistake. Anyway, just wanted to discuss how they approach the problem here. So it says a brave player is being pushed backward, So you can imagine they're in contact as they're pushing on each other, and the force between them is 800 newtons, right? It says exerts a force of 800 newtons on him, but he also exerts a force of 800 newtons on the other player because they are in contact. It's Newton's third law. Okay, and it says he is accelerating at 1.2 meters per second squared. Well, they both are. Because they're, it says being pushed backwards, so they're in contact. And part B says, what force does the winning player exert on the ground to move forward if his mass plus equipment is 110 kilograms? If you look at their drawing, system B, system for question part B, it's not a good drawing because they're not even touching each other. So let's draw his hand sticking out a little further, and this guy's hand sticking out a little further. Okay, now they're in contact, and then the 800 Newton force that they're exerting on each other is internal to the system. But you can see that there's a force here that the bigger player is he's actually feeling. That's the force he feels from the ground as he pushes on the ground. And this smaller force, 692 newtons, is the force felt by the ground of the smaller player as he pushes on the ground. Okay, so these forces are both trying to move the system, but we don't actually know the 932 newtons. So you can kind of pretend like you can't see that value right there, and then look at how they set up the equation. They said, okay, F equals ma, but there's two forces, F minus F. So notice this force right here is in the negative direction, so it's minus F, and then this force right here is in the positive direction, and that's why it's positive F. So it's F minus F equals ma, where m is the mass of the system. Okay, so they've rearranged the equation. They added f, small f, to both sides of the equation to get F equals ma plus F, substituted for m, the mass of the system, and again they're able to use A for the system because the two players, is being pushed backward. So it's like it's not happening in an instant, it's happening over a period of time. So they're accelerating at the same rate, and then we substitute from 692, which was the answer from part A, and then just the math works out to get 932 newtons. The other way to solve the problem would be to treat the 110 kilogram person to treat them completely on their own, not as a system. And you could actually still solve the problem because it says what force does the winning player exert on the ground to move forward. And you can I'll show the solution for that. So let's clear up my screen. How do I do that? Oh, well, I just deleted everything. Whatever. See, hopefully I can fix it. I apologize. I'm using my mouse, so it's going to be kind of messy. I left my iPad at school. So if you were analyzing just the larger player, right, and I'll draw it in the same representation as shown right here. So if I were just drawing the larger player, now I'm modeling just a larger player, so that 800 Newton force felt by the smaller player pushing on him, that is now not an internal force, it's an external force because we're only modeling this player right here. So that's the push from the other player. This is the unknown force that the ground is pushing on him and that he is pushing on the ground. All right, and then of course we have mg, that's his weight, and then we have the normal force counteracting the weight. But what we really care about is acceleration in the x direction. So make sure when you write Newton's second law, you indicate what direction. I'm going to write x because the players are accelerating in the x direction. All right, so I only care about these forces right here because those are my x direction forces. All right, now I can actually decide which way is positive. So the bigger player is gonna win. So we'll call this direction positive. So this force is positive, and this 800 newtons is negative. So when I substitute for sigma F, I get 8F minus 800 equals, and now the mass is just 110. So 110 kilograms because we're just modeling that one player. And then we know the acceleration is 1.2 meters per second squared. I'm kind of ran out of room there. Apologize. So this, when you add 800 to each side of the equation, you get 132 newtons. That's from multiplying these two values together, plus 800 newtons, and then you get 932 newtons. 932 newtons. So notice in this case I just modeled the larger player and I still got the force on the ground, and that was the exact same value that you could get by modeling the two players together as a system and ignoring that 800 Newton internal force.